Ladies and gentlemen, colleagues, welcome to Leonardo Energy Academy, and welcome to this short lesson on cable selection. First of all, let me try to explain my language. For me, cable selection and cable sizing are two different processes. Cable selection is the process of selecting the appropriate type of cable, while for a given type of cable, cable sizing is just the process of selecting the appropriate size of the core, the appropriate size of the conductor. Today, we will discuss cable selection. Let me repeat the type of the cable. Indeed, for cable as well for any other kind of equipment or kind of things, to select properly something, we have to know deeply what we are selecting. And then today we will start from the main cable classification, moving to main cable parts, and then additional details on type of conductors, kind of insulations, filler, sheet, screens, and armor. For all of them, we will try to put in evidence the limits, the possibilities offered by technologies, and the pros. Probably the main classification of cable is done on the basis of voltages, of rated voltages. From this point of view, cables are a bit different from other equipment. That is, they are characterized by 2 or better 3 rated voltages, U0, U, and UM. U is the rated voltages between 2 lines, and U0 is the voltage between 1 line and the ground. UM is exactly the same for all other kind of electrical equipment, and it is the highest voltage for the equipment. That is the highest value of the phase-to-phase voltage for which the equipment has been designed. That is the highest voltage for which the equipment has been designed for continuous working. So, using this classification, the cables can be classified as done for any other kind of equipment into the 3 main classes: low voltage, medium voltage, and high voltage. Just a moment, I am not sure that everything is going properly. Main cable classification by voltage means that we have 3 main classes of cables: low voltage power and control cables, medium voltage power cables, and high voltage power cables. Low voltage with a rated voltage up to 0.61 kV, that is UM 1 and 2 kV. Medium voltage from 1 and 8, 3 kV to 1830 kV, that is with UM between 3 and 6 and 36 kV. High voltage from 2645 kV to 220, 308 kV with the corresponding UM. Generally, indeed, we have to select a cable with a rated voltage equal or greater than the rated voltage of the system in which it will be used. But there are also some exceptions due to local regulation or due to international state of art. Let me mention first of all that in comparison with other electrical products, cables are internationally standardized, but locally they are quite different, also in a very close region. So today we will discuss just the main concept valid everywhere. It still exists the possibility that locally some additional rules, some combination is different. So coming back, voltage greater or equal than the voltage of the system, with some exception. For example, if I need to set up a double insulated system, I should adopt equipment with a double insulation, the double square. But we don't have cables with a double insulation. Internationally, the rule is to select a cable with a rated voltage of one step more than the minimum required for such system. For example, in a low voltage system, 230 volt, I have to adopt, to guarantee double insulation, a cable 061 kV, and so on. Underground cable, at least in Europe, even for a low voltage system, have to be minimum 061 kV. For lines, for example, characterized with different voltages but in the same cable pipe, I have to adopt the rated voltage equal or greater than the maximum voltage in both the systems, and so on. Sometime, as we will see at the end of the presentation, I can also reduce the voltage in comparison to the maximum foreseen. So let's move now to the anatomy of the cable, and let's start saying that single core cable are quite often called wire, while a multi-core cable are called cables. I would prefer to call all of them cables, single or multi-core, but this kind of language is commonly used, and so we will also adopt it. The main, the art of the cable is indeed the conductor. No cable without conductor. Sometimes this is all, that is, the insulation is guaranteed just by the air, but more often around the conductor I need a solid insulation made by plastic or something similar. I can add something more, that is a sheet, again typically made by some insulating material, let's say for the moment to help the insulation, or better to protect the insulation against environmental aggressive conditions. This was a single core cable. This is exactly the same but referred to multi-core cable. Again, a conductor, or better more than one conductor, and to keep the shape rounded. In this case, I have also another component in addition to the sheet, and this is the filler the light gray just for fill this empty space if needed. Indeed, the conductors can be different with different shapes. I can also have a bedding or a concentric PA in such cases, or also an armor or a screen. This is represented in this schema by the dark gray circle. Another completely different kind of cable used just for in low voltage system are the cable with mineral insulated. That is cables in which the insulation is guaranteed by oxide magnesium instead of plastic. They have a conductor solid made by copper, and the sheet is still made by copper. If in case I can have another additional sheet made by plastic. The sheet is also the concentric P conductor. Moving to medium voltage and high voltage cable, indeed the structure is still very similar. The core is the conductor. I have the insulation. Indeed, in these cases, the insulation plays a role much more important than for in low voltage cable. I have a sheet practically every time. A bedding I can have, or better, I have a screen and an armor. And additionally, I can have a conductor screen and or an insulation screen, typically made by semiconductive material. This is the single core, and this is exactly the same, but multi-core. Low voltage cable and wire designation. In this case, I have to refer to some specific region around the world. As I am in Europe, I will provide this example referring to the European system of designation. Typically, this is something that describe with some given rule the cable. You can see is a series of letters and number, and in each place the letter or the number means something for a given piece of the cable. That is exactly the pieces we just presented. For example, referring to this European practice, the first letter describes the cable standard, H for harmonized cable, N for national unauthorized, S for special, and so on. It's strange to see in a standard N for national unauthorized. This is not theory, is practice. We still have, and probably we will have also for a long time, a lot of national practice not harmonized. Then in the second place, I have the 2 digits to represent the voltage. For example, in this example, 07 means 450, 750 volt. And then I have the insulation material. V means ordinary polyvinyl chloride. Then if any metal coatings, some details, if any, for special construction. If available, the insulation sheet, in the example again PVC. The place for the conductor materials, no symbol means copper, A means aluminum. And then at the end, the conductor shape. F means flexible conductor or flexible cable. This is another example, very similar to the first one, but the rated voltage 0.5 means 300, 500 volts. The last example is again very similar, simply the insulation material changed. R means equivalent synthetic elastomeric rubber, while N simply means polychloroprene. This cable exactly is a cable for mobile usage. So let's move more in detail on the cable selection. Indeed, cable selection as well as selection of any other kind of equipment is to define a product, to define a component of the electrical installation suitable to face the stresses that it will have in its life. These are electrical stresses, let's say working voltage. I should have also to say working current, but in my classification, working current is in the chapter of cable sizing and not cable selection, because this affects practically just the size of the conductor. And then environmental conditions, that is typically temperature, fire, water, chemical, or sunlight exposure. To be more academic, I should have said just for all of them physical stresses, because voltage or any other kind of stresses are still physical. But practically people prefer to classify stresses in this way. The last class of stresses are the one of mechanical stresses. In such case, or better, these stresses affect conductor flexibility, that is more in general cable flexibility, form and composition of the outer of the cable. Basically, these mechanical stresses as well as environmental stresses are to be referred to the working condition of the cable as well as to the installation phase of the cable. For sure, this is very important for mechanical stresses, because during installation, in certain cases, the cable can be stressed mechanically much more than during its life, and this is to be taken into account selecting the cable. So, keeping in mind this perspective, let's move to each part of the cable to discuss the main possibility we will have. And let's start from the heart of the cable, the conductor. The scope of the conductor indeed is for carrying current. Number of conductors, we have a single core cable, we already mentioned, and a multi-core cable. The official way to indicate, to specify a single core cable is to write 1X. While for a multi-core cable, I have to write 2X for 2 cores, 3X, 4X, and so on. If instead of X I write G, this means in any case that I have the given number of cores, but one of them is for PE, that is for protective earthing. That is, its color is yellow-green. There is no other differences between, for example, 3X and 3G, except for the color of one of the cores. But indeed, in specification, this could be important. Comparing the two main possibilities for conductor materials, indeed we have to compare copper and aluminium, because for power cable practically these two materials cover 100% of the market offer. More or less, copper is better than aluminium from any point of view. That is, electrical conductivity is higher than aluminium. In the table we can see the rate between the two conductivity. For the same conductivity, the space required by aluminium is larger than copper. The tensile strength not negligible. This is quite often neglected by electrical people, simply because it's from the world of mechanics, but in the real life it's very important also for cable. The mechanical strength of copper is better. The tensile strength for the same conductivity is still better. Indeed, aluminium has less weight than copper. The coefficient of expansion is still better for copper than for aluminium. Also, from the point of view of connection, that is the possibility to work on the cable at the building site, copper is easier to be worked than aluminium. But we will come back on more in detail on this comparison in a specific lesson. Shape of conductor. The main one is circular, but we can also have other alternatives, for example, oval or shaped. This indeed is to have a different shape for the final cable, or to have for the same section a lower diameter of the final cable, because with the circular sometime I need more filler than copper. Type of conductor. We have two main classes, solid and stranded. The solid conductor is made from a single solid metal piece. It is the less expensive, and it offers an excellent environmental and corrosive resistance. Indeed, in comparison with the stranded conductor, the surface area is reduced. The stranded conductor is made by a series of several small wound put into a single larger conductor. It is more expensive to be manufactured, but it is more flexible than a solid wire. And comparing different places in the world, I noticed that in some region people prefer flexible cable simply because also during installation stage they are easier to be installed. In some other region this is not an added value. We have also other variety of solid or stranded, that is flat strap, flat braid, and tinsel. But these are additional details that we can leave to further personal reading. Type of stranding. Again, the stranding can be done in different ways. We have four classes: bunched, concentric, unilay, and rope lay. Bunched is made, in bunched the strands are gathered together. In concentric and unilay, strands are arranged in a circular pattern, and in rope lay, strands are arranged into cable groups. The first is the simplest, the last is the most complicated. Indeed, each one of them have some pros and some cons. It depends on the application. More or less, let me say that strength affect flexibility. If we are interested in flexibility, we have to pay attention to strength. Let me repeat, flexibility during installation and flexibility during usage. Let's move to insulation. This is a very important chapter and it's strange because the core of the cable is the conductor, but we have probably much more variety of insulation than of conductors. The scope of the insulation is indeed to insulate the conductors between among them and between them and the ground. This is chemistry. Practically today, except for mineral cables, all the insulating materials used for cable come from polymers. In the past, we used also paper, but now polymeric insulations are definitively much more important. Polymers can be natural or synthetic. Looking to the market now, natural polymers are not still used, and we have to refer just to synthetic polymers. We have four classes of polymers, synthetic polymers, three classes of synthetic polymers, elastomers, thermoplastics, and thermosets. All of them give to the cable different behavior and different characteristics, and so it is better to know a bit of their chemistry, or at least to remember the name of the classes. What are the physical requirements to which we have to pay attention evaluating any insulation material? Between brackets. We are discussing insulation material, imagining that we want just to specify a cable, that is, we are users, so we are designer of electrical installation. We are not designer of cables. Indeed, this involves a lot of other classes of topics, basically more related to mechanicals and to chemistry. By the way, looking the cable just from the point of view of the user, I should have been interested in the elongation, in the tensile strength, in the dielectric strength, in the temperature rating, in the flexibility, in the flammability, that is in terms of ability to burn and emission in case of burning. We will dedicate a specific lesson to this topic. In weatherability, that is the ability to withstand abrasion, to withstand the chemicals, water and weather, and indeed in specific gravity, that is the weight in comparison with water. In this table we have some typical parameter for the main types of insulation material. In case of reference, this could be helpful, but indeed it's quite boring to be discussed now together. Let's move to the three main classes. Thermoplastics. Thermoplastics are solid insulation materials that can be softened and made to flow by heating. And they can be extruded onto wire and quenched in cool water to make solid again. That is a thermoplastic, but is also in the name, are affected by heating. The most used the thermoplastic material is polyvinyl chloride, PVC, and I tried to represent it from the perspective I mentioned with a table of 5 rows. I did exactly the same for other kind of insulations. Flexibility, it is good from this point of view. Fire not propagation, good. I specified fire not propagation because with cables we are interested in avoid propagation of fire. So I tried to avoid misunderstanding, putting the smile with fire propagation because someone could have thought this propagate very well fire. Good means it does not propagate fire. Emission in case of fire. Unfortunately, PVC produce a lot of smokes in case of fire. This because of chloride. Chloride is good to stop fire, but unfortunately it is quite dangerous. Temperature is quite low. 70, the working temperature is 70, short circuit temperature 160. In comparison with the other one is quite low, and we have to take into account in some specific situation. For example, inside an electrical board, the temperature is typically quite high, and also looking to standards of protections, I can discover that the working temperature of the pole of a protection is more than 90 degrees. So the last part of the cable can be subject to quite high temperature every day. PVC is not good for cabling inside electrical board. Water, PVC is good also to be used underwater or in case of water. PE is another thermoplastic. In comparison with PVC, you can see that the temperature is the same, but other characteristics of pure PE are not enough good. For this reason, typically it is used cross-linked. Thermosets, that is the second class. Thermosets are insulating material extruded onto wire and then subject to heat and pressure that undergo to a chemical change known as cross-linking. The most used, the most common thermoset used in cables is XLPE. XLPE is cross-linked polyethylene produced from polyethylene under high pressure with organic peroxide as additives. Flexibility, unfortunately, is not very good for this kind of insulation. Fire propagation is good. Emission is, in case of fire, are depending on other additives put into the XLPE, that is technologically industry add something to increase not to increase the emission, but to enhance the emission in case of fire, that is to reduce the emission, but with reference to water, XLPE is not good because it has the problem of water treeing. that is practically it absorbs water. Let me say it absorbs water because I am an electrical engineer, probably a chemical engineer would have said something completely different, but the concept is this one. Temperature. Temperature is much better than PVC, 90 to 250 in case of a short circuit. Let's just comment a bit more flexibility. As flexibility is not so good, but electrical strengths are good, XLP is more common for higher voltages, but in some region it is also used for low voltages when the market is not interested in flexibility. Elastomers. Elastomers are polymers having at the same time viscosity and elasticity, and characterized by a very weak intermolecular forces. The most common synthetic elastomeric material used to manufacture cable is ethylene propylene rubber. Practically all the characteristics we listed are good, flexibility good, fire propagation good, emission in case of fire intrinsically good, even if we can also add some additive to enhance performances. Temperature is exactly the same than PVC, and water resistance, behavior in case of water is still good. Silicon rubber. Silicon rubber is another synthetic elastomer used for cable. In such case, the general characteristics are very similar to the one of ethylene propylenic rubber, but the temperature is also higher. Working temperature 150 Celsius and short circuit 350 Celsius. EVA, I don't know if in English we have to say EVA or EVA. By the way, we can see as it is written. Flexibility is good, fire propagation good. Unfortunately, emission in case of fire is not so good. Again, we have to consider additives. Temperature is good, 90 to 150, and water behavior in case of water is still good. Magnesium oxide insulation, that is, I am referring now to mineral insulated cables. Let me repeat, available only for a low voltage system. The weak point of this kind of cables is flexibility. Practically they are the tubes of copper, and so to work on them, the technology and the practice is completely different than other plastic cable, but fire propagation is excellent, emission in case of fire is excellent, temperature is excellent, and water behavior is good or better. Magnesium oxide is not good with water, but simply in this kind of cable, water cannot reach the magnesium oxide, so I should have put there two smile, but to remember to mention this issue, I put just one. And also because this slide is dedicated to magnesium oxide and not directly to the cable. It is good is the behavior of the cable, so is the behavior of the insulation. Let me mention temperature, 250 to 1000 degrees. This is the reference of the insulation. This means that considering that typically the temperature of fire is 700 degrees, literally this kind of insulation does not burn. Additionally, theoretically, I could also work temporarily to temperature more than 1000 degrees. But in such kind of cable, the limit is not the insulation as in all the other cables, but the limit is in the conductor. That is, with copper, the limit become 1083 degrees. In any case, much more than all other kinds of cable. Let's move to semiconducting screens, and let's approach the end of this lesson. The insulation screen and the conductor screen typically consist of carbon-loaded polymer compound cross-linked with insulation. They are there to control the electrical field, and typically they are used just for medium voltage and high voltage cable, not in place for low voltage cables. The sheet, as we mentioned, the sheet is there, if any, to improve mechanical behavior, waterability, chemical behavior, and also indirectly, let me say, electrical protection. Materials used for sheet are more or less the same materials used for insulation. But formally we have to distinguish sheet from insulation. Screen and armor. I prepared just one slide for screen and armor together. Probably it was not a good idea because the scope of the armor is to protect the cable against mechanical damage, again during installation and during service, while the scope of the screen is to protect the cable against electromagnetic radiation, or to protect the surrounding against the electromagnetic emission of the cable. We have different types of screen and armor, round or flat wires made by steel, galvanized steel, copper, thinner copper, aluminum alloy, or a copper tape, or tapes of steel, tapes of galvanized steel, tapes of aluminum, and so on. All of them are conductive and are put between the insulation and the sheet. Just pay attention that for single core cable we have to select non-magnetic armor or screen, because otherwise we will have heavy current inside the armor. The filler is indeed important for having a good cable, but from the point of view of a specification of the cable, this is just something additional, and we have not to pay now too much attention on this. Let's conclude with this table and two examples. I tried to summarize in this cable different types of cable, referring to the designation used in Europe to be used in low voltage for main connection, distribution, fire control and emergency lines, data center, HVAC connections. Let's say in general industry or general building. in special industry like petrochemical or ships and so on, we usually adopt special kind of cables, and we are not paying attention to them now. So the first class I called class A is single core, I should have said wires, single core cables, the simplest, made, let me see, made by PVC. All of them are made by PVC and suitable for installation into conduit or pipes. The second class B is the class of cables, single core or multi-core, typically insulated, let me see, with EPR or XLP, without any special characteristics. The third class, C, is listing wires again, but with the special characteristics in terms of emission in case of fire. And the same is for class D. In such case, cables, rubber cables, but with reduced emission in case of fire. Class E is the class of cables with the ability to withstand fire, that is to provide the service also in case of fire. Class F is listing cables screened. Class G, armored cable, that is cable able to withstand to special mechanical effort. And the last class, again, cable able to withstand to special mechanical effort because of service. That is, these are very flexible cable to be used in mobile application or in robotics and so on. Before to conclude, let me mention two, from a given point of view, two special classes of cable, but more and more important in the panorama. Photovoltaic cables. Photovoltaic cables are cables good, specially designed for photovoltaic installation. Why we need a special cable for photovoltaic installation? Basically because of solar radiation. That is, typically this kind of cables has to withstand to solar radiation for a long time. That is, typically in a photovoltaic system, I would expect to avoid to change cables for 20 years, let me say. And so you have to be guaranteed on this. The one I am showing you is an Italian one. The insulation is a cross-linked elastomeric rubber, halogen-free, HEPR, called G21, and the sheet is again a special cross-listing elastomeric rubber called M21, still halogen-free. Temperature 120 to 150, that is more than the classical EPR, and again good for this kind of installation. Something interesting is 1 and 8 kV also to ground DC, direct current. This formerly was not low voltage, but in comparison with the first table we commented today, should have been medium voltage. Formally, this has been defined low voltage because the actual trend in photovoltaic is to increase the DC voltage over 100 kV and so on to have to increase the power with the same current. So this is a trick, this is a formal trick of the standard to allow the usage of this kind of special cables. Another perspective is the one of electrical vehicle, and then the need of a flexible cable to charge electrical vehicle. The industry started to prepare a special cable to do this. This is an example, the Italian one. Indeed, this kind of cable is quite special because it is foreseen to carry a quite large power. It has to be used also by not specialized people. It involves the problem of environment, the problem of weight, problem of flexibility, and so on. By the way, this is just to say we also have a lot of special cables to be used in special situations, and they can vary from a region from another one. That's all, and thank you very much.